All right. Hi, everybody, and welcome to National Family Code Night. My name is John Pierce. I'm the director of Family Code Night and of our new organization, CSisElementary.org. It's a new national movement for K-5 computer science education. We're really glad to be with you here tonight. And let me start with a little bit of appreciation. We are very happy to be with you tonight and to be with you with the help of our partner, the Infosys Foundation USA. Infosys Foundation USA has supported our work for years. It's a wonderful foundation, wonderful organization. And I want to call special attention to a place they have called the Pathfinders Online Institute. And at the Pathfinders Online Institute, you can find all kinds of resources for computer science and maker education for families and teachers anywhere in the country. It's all free, and you just go to Pathfinders Online Institute. You'll find all sorts of wonderful things there. I also want to introduce my co-presenter tonight and partner helping out on tonight's National Family Code Night. Julie, you want to say hi to everybody? This is Julie Troy.
Hello, everyone. It is so good to be here with you all tonight. Like John said, my name is Mrs. Julie Troy, and I'm over there in the YouTube chat. So happy to be there. If you guys have any questions, please throw them my way. I will also be helping out with our prize drawing later this evening.
That is awesome, and that's going to be pretty exciting. We are really looking forward to that prize, and we'll be telling you more about that as we go forward today. So super happy to be with you tonight, and let's jump right into it. You know, we're doing Family Code Night tonight, and there's really one thing that we'd like all you kids and parents to learn more than anything else, and that is this simple fact. It is, kids, you can code. The truth of the matter is, you kids are going to have a digital future that we can hardly imagine. And you know, we all love to play with computers and to use our computers and play video games and all kinds of things. But you know, even more fun than playing with what's on the screen of the computer is creating what's on the screen of the computer. And that's the difference between just consuming what the computer offers you and actually creating it. That's what computer science is about, and that's what coding and software are about. And you know, it's great fun. I know kids in second grade who have built their own games. They're wonderful games. They're really fun. But you know, it's even more than just fun because it's so important for the future. And parents and kids, it's really important to see almost every field in our world is being redefined by software and technology. You know, if you think about it, we used to buy everything in a store. Now we buy lots of things online. You know, farmers, they used to drive their tractors and have to be very careful about exactly where they went. And now they use global positioning satellites to automatically drive their tractors with tremendous precision. Cars, you know, today we drive them ourselves, but a few years from now, cars will drive themselves. They'll come and pick us up and take us where we want to go. Or automation. Every field is being changed by technology. And you know what underlies all those changes? Software. People writing code and telling computers what to do, building that digital future. So kids, as much fun as it is to play with computers, it's going to be even more important for your whole life about learning how to use computer science, learning how to do coding and think in terms of computational thinking. And the more you learn this, the better your future is going to be, and the more creativity and fun you're going to have. So that's the most important lesson we have for our National Family Code Night tonight is you can code. You know, Family Code Night started a few years ago when we helped thousands of schools all over the country host these events. But you know, when COVID came along, schools stopped doing in-person events at school. And so we started offering Family Code Nights all around the country to any school. And I'm thrilled to say tonight, we have more than 100 schools with us tonight, and probably hundreds, even thousands of people from all over the United States. So we really appreciate all the schools that are participating, and we're so happy to have you with us here tonight. So that's about enough for the introduction. Let's jump into how our program is going to work and what we're going to be doing tonight in our National Family Code Night. Our program tonight, we're going to do Hour of Code puzzles. Now, some of you kids may have done Hour of Code puzzles in school. I want to ask a special favor of you. Be patient with your parents. You can show them how these puzzles work. And if you haven't done them before, I think you're really going to enjoy it. So we're going to be doing Hour of Code puzzles, but we're also going to do something more. we're going to teach 6 big ideas in computer science that are really nicely illustrated by those puzzles. So we'll be trading off between doing puzzles and learning about computer science and technology. And then finally, we're also going to have our contest. And actually, before I go any further, let me give you a preview of what we're going to be giving away in tonight's contest. It's the Robotics Home Bundle featuring Dash the robot from Wonder Workshop. We want to say thank you so much to the Wonder Workshop people for providing these wonderful prizes for us. This is Dash. Howdy do to you too, Dash. So this is Dash the robot, and it's a wonderful robot that you can program to do all kinds of things. And in the Home Robotics Bundle that we're giving away tonight, a couple other things you get along with it. One is all these Dash challenge cards and step-by-step instructions for doing all kinds of really fun robotics projects with Dash. And even better, the Gripper building kit. 2 arms that you attach to Dash that let him grab things and do all sorts of additional tasks. And so this bundle we're giving away tonight in a drawing at the end of the program, and really hope you guys win. So happy to be with you here tonight, and I really hope you have good luck in our contest. So how is our event going to work tonight? Well, we're in Zoom right now, live streaming to YouTube, and most of you are watching us on YouTube. And so you'll be here in this tab of your browser, watching us in the live stream as we teach these ideas about computer science and as we give you tips on how to solve the puzzles we're going to be doing, because the puzzles get a little harder as we go, and you'll want to come back and make sure you get those tips. But then we'll pause and you'll go to a separate tab in your browser where you'll actually do the puzzles. And I'm going to show you exactly how to do that in just a second. So you'll be going back and forth between 2 tabs in your browser. One for our live stream here on YouTube, and a second tab that I'll show you how to open in just a second for the puzzles that you're going to be doing. Now, there's some rules to make tonight's program as good as possible, and here's the first one. These puzzles are self-paced, and there's no rush. When you finish one puzzle, you'll be automatically taken to the next one. So don't worry about a thing, and you don't have to hurry. Go at any speed you want. Everybody should be working in a 2-person team. We call it pair programming, and we should have 1 computer for every 2 people, and you share the computer. And this leads us to probably the hardest rule of all to follow, and that is you trade the keyboard after every puzzle. Now, this one's a little hard because a lot of times if you're doing it with a parent or an older sibling, maybe the parent wants to really watch the child do the puzzles and the child doesn't want to give up the keyboard. But no, that's not how Family Code Night works. This is all about collaboration and working together. And you're going to need each other because you're going to need to figure out the logic of each one of these puzzles. And so you're very much a team. The person with the keyboard we call the driver, and they'll do the coding and they'll do the programming to solve each puzzle. And the other person we call the navigator. And the navigator gives advice and helps discuss how to solve the puzzle you're working on. After every puzzle, you trade the keyboard to the other person and you trade jobs. So that's a really important lesson, one we hope that you can follow tonight with your mom or dad or whoever you're working on with on tonight's program. Next rule is turn up your volume and set your browser to full screen. These are wonderful, fun cartoon characters we'll be playing with, and it's really fun to see them at full screen. So that's about it. You're going to be in 1 tab of your browser to do the puzzles, and you're going to return to this other tab where we're here in Zoom live streaming via YouTube. So that's the way the program is going to work. So now that we've covered the rules, we're ready to learn about the programming language that we're going to be using tonight to share the puzzles. And there are sort of 2 kinds of programming languages. One is called character-based programming, where you have to type every character of your code. And the other is called block-based programming language. And the puzzles we're doing tonight are from code.org. And code.org has created a really wonderful little video that will introduce you to Blockly and show you exactly how to solve these puzzles. So let's jump over to the video here from code.org about Blockly, and you'll see just what I'm talking about. So in about 2 minutes, you're going to learn all about Blockly, and then I'll come back and we'll move on from here.
I was in 8th grade when I learned to program.
I first learned how to make a green circle and a red square appear on the screen.
You just learn these lessons, and there aren't that many of them, and you just eventually can get to the point where you can do almost anything that you want.
Computer science is just learning how a computer works and how it thinks so that you can teach it to do new things.
These days, what you can do in computer science is pretty much amazing.
I think it's the closest thing we have to a superpower. In the next hour, we're going to play a game that will teach you the basic concepts of programming. Usually programming is all in text, but we'll use Blockly, which uses visual blocks that you drag and drop to write programs. Under the hood, you're still creating code. To start off, we're going to build code for a program that will help this angry bird move through a maze to get to the evil pigs that stole its eggs. Blockly is split into 3 main parts. On the left is the bird's maze, where your program will run. The instructions for each level are written below the maze. This middle area is the toolbox, and each of these blocks is a command that the bird can understand. The white space on the right is called the workspace, and this is where we'll build our program. If I drag the move block to our workspace and press run, what happens? The bird moves forward 1 box on the grid. And what if I want the bird to do something after the move forward on 1 box? I can add another block to our program. I'm going to choose the turn right block, and I'll drag it underneath my move block until the yellow arrow appears. And then I'll drop it and the 2 blocks will snap together. When I press run again, the bird will perform the commands that are stacked from top to bottom on our workspace. If you ever want to delete a block, just remove it from the stack and drag it to the trash can. After you've hit run, you can always hit the reset button to get the bird back to the start. Now let's get those pigs.
All right, let's go get those pigs indeed. All right, so now what I'd like to do is show you how you're going to get to the puzzles and then how we're going to go from puzzle to puzzle. So what we're going to do now is jump over to our browser, and in just a second, I'm going to ask you to come to this page, and I'll show you the URL in just a second. But for now, don't go to this page quite yet because I want to show you how to do this. You're going to go to familycodenight.org/start. And again, I'll give you that URL in just a sec. And you're going to click on the Start the Program link, the big Start the Program link, top center of the page. And when you click on that, you'll be taken to the first puzzle in the Hour of Code, code.org puzzles that we're going to be using tonight. The first thing you'll notice, by the way, is that the video that we just watched opens up on your screen. You can go ahead and hit the close box to close the video to move on to the first puzzle. And by the way, other videos will pop up as you go through the puzzles tonight. You can watch them if you want, but you don't need to. I'll be telling you everything you need to know here. When we go to the first puzzle here, you can see it's just like she described. The directions for every puzzle pop up right here at the top. Can you help me catch the naughty pig? Stack a couple of move forward blocks together and press run to help me get there. So the instructions are always right at the top of each puzzle. Then you drag a move block out and snap it onto another block. You hit run to try and run your program. So the basics are all right here, just as she described. And one thing I want to point out, if there are any Spanish speakers with us or anyone who speaks any language, there's a wonderful little function down here in the bottom left of every puzzle. You can click where it says English right now, and you can select any language you want. And that language will replace English for the directions and what you see on the screen here. So if it makes it easier to change to a different language for those instructions, please go ahead and do that. So that's about it. I am going to let you guys go right now. And then what I'd like you to do is go to puzzles 1 and do puzzles 1 and 2. And you're going to do that by going to this URL right here, as I just did myself. You're going to go to familycodenight.org/start. And just the way I just did, hit that Start the Program link, the top center of the page. And when you do that, you'll be taken to that first puzzle, just as I was just now. familycodenight.org/start. And you'll go to the first puzzle that you're going to be completing. When you finish that puzzle, you'll be automatically taken to the second puzzle. So just drag the blocks out and connect them, and then hit that run button, and you'll see exactly how to do that. In fact, I'm going to jump over right now, and we'll demonstrate that first puzzle one more time for you. So you see the directions up here. You drag a move forward block out, snap it to the other block, and if you look at what the bird has to do over here, that makes sense. The logic of our program that we're writing makes sense, because if you look at the bird, he has to go 1 space, 2 spaces forward to get to the pig. And so sure enough, our program is going to be, when we run our program, we're going to move forward once and move forward twice. And I think that's going to get us all the way to the pig. But I'll tell you what, I'm not going to run my program. I'm going to let you guys go solve this puzzle on your own. So go ahead and again, go to familycodenight.org/start in a new browser tab, and then build the program you think will solve this puzzle. Come over here and hit that run button and watch what happens. And I'm going to see you in just about 2 minutes because I'm going to show you a couple things on puzzle number 2, and we'll review a few things together here when we do that. So again, you want to go to familycodenight.org/start. And when you get there, close the video that we just watched and do the first 2 puzzles. And I'll see you in just a minute. All right, everybody, come on back to the live stream tab of your browser, and let's go to puzzle number 2 together. And I'm going to show you a couple things about puzzle number 2 that are good to know about. And then we're going to learn our first big idea about computer science. We're going to learn 6 big ideas about computer science tonight. We'll learn our first one in just a second. So, we were just looking at puzzle number 1, and let's jump forward to puzzle number 2 here. And puzzle number 2, same kind of puzzle. Here's our bird, and he has to go forward, forward, forward 3 times to get to the pig, right? So as we've learned, we're going to drag out our blocks and connect them together. And by the time we have connected 3 of our blocks together, I think that program is going to solve our puzzle. We'll take a look and make sure in just a second. But I want to show you a couple other things about Blockly here. First, you can, if you want to move blocks, and if you want to move more than 1 block, grab the top block of the stack you want to move. And look, you can move 3 blocks at once, and it makes it a little easier to move lots of blocks around. As we go forward, you'll notice new blocks appear in your blocks area. And these are adding more and more power to your programming. And so the new blocks have new capabilities, and we'll talk about those as we go forward. If you want to throw away blocks, you can just drag them over here back into the block space, and it's no problem. You can get rid of blocks that way. If you run into trouble, you'll notice that the run button turns into a reset button, and you can reset to go back to the beginning of this puzzle. So those are the main things that we want to review here in Blockly, some of the ways to use Blockly. Now let's run a program and let's see if we can't solve this puzzle. I think this puzzle is going to be move forward, move forward, move forward. Let's run it and see. There's our bird. Pig looks worried. Oh! All right, we got him. Very good. All right, now this brings us to our first big idea in computer science. So let's jump right into that. Computer science, a lot of times these ideas can sound pretty complicated. You did puzzles 1 and 2. Good job, everybody. But our first big idea is, what is a program? When we talk about coding, we're talking about writing software and building programs or building software. And those are all related expressions. Well, what is a program anyway? Well, you just wrote a program. You just wrote maybe your first program. A program is just a list of instructions that you create to tell a computer what to do. And this is what almost all computer programs are. And so it's all about thinking about the instructions you need to give to the computer to solve the puzzle. So that's our first big idea in computer science. You've learned it on your very first puzzles. And now what I'd like you to do is go ahead and do puzzles 3 through 6. And I'll come back at puzzle number 6, and we'll learn our next 2 big ideas in computer science. And I'll see you in just a minute at puzzle number 6. By the way, as we go along here, if you want to, you can drop into the chat area in the live stream what puzzle you're on, and Julie and I can keep track of where you are, and we'll be able to time when we come back and visit again in just a couple minutes. So see you in just a couple minutes. Go on and do puzzles 3, 4, 5, and if you can, do puzzle number 6, and I'll see you in just a minute. By the way, in case anyone arrived late, let me just remind you that the way you get started is by going to familycodenight.org/start. familycodenight.org/start. And I think Julie probably dropped this into the chat area in the live stream. And when you go there, there's a big link at the top center of the page. It says start the program. Click on that. There's a little video that will come up and teach you about Blockly, the language we're using. You'll have no problem catching up, I hope. So go ahead and join us there. As I mentioned before, drop what puzzle you're on into the chat area every once in a while. It'll help us out timing our remarks tonight.
I have to say, we have a wide range of families, students, people from all over, and lots of different grades. So I know some of you are getting to puzzle 4, puzzle 5, that's great. There's a couple of you in there who, puzzle 10, what? Puzzle, some of these, I don't know. I don't even know if I believe this. This is impossible. But good work, you guys. It looks like I think we're just about ready to move on. Okay. And if you're not there yet, don't worry.
That's great. And we do have kindergartners and we have 5th graders. So you 5th graders and you speed programmers, take your time, relax a little bit. We want to take care of the littles as well. We're really happy to have everybody here with us tonight. So congratulations on your progress. And for some kids, this might be the first time you've really done any coding or programming. We're so proud of you to be here with us tonight. So congratulations to everybody. Now, let's jump forward to puzzle number 6. And I think we're ready for our next couple of big ideas about computer science. And on this puzzle, this is really kind of cool because they introduce a new and very powerful kind of block that we're going to use right now. Here's our bird for this puzzle. And you guys have already built a few programs. And so you know how this works. The bird has to move forward, move forward, move forward 5 times to get to the pig, right? So we can drag out the move forward blocks. 1, 2, we can drag out enough move forward blocks to solve this puzzle. But hold on a second. Imagine if the pig was 100 spaces away. Imagine if the pig was 1,000,000 spaces away. Can you imagine how long it would take to drag that many move forward blocks out to get all the way to the pig? You'd be stacking blocks all day. Well, that's the beauty of the new block that we gain on this puzzle. It's called the repeat block or the repeat loop. And what it does is really special. It will repeat any block or blocks that you put inside of it as many times as you say. It makes you much more powerful as a programmer. And so in this case, look at our bird. He has to go 1, 2, 3, 4, 5 move forward blocks. Well, all we have to do is drag out 1 move forward block, stick it inside the repeat loop, and have it repeat 5 times. And by the way, if it was 100 times, we could change the number here. And remember, you're the programmer. You can tell the computer exactly what to do. And so in this case, we don't need 100, we just need 5. But if we need 100 or 1,000,000, we could just change that number. Imagine how powerful that makes you as a programmer. So let's run our program and see what happens. I'm liking our chances here. Now we're working with just 3 blocks, and look how much work we're going to get. Here's our bird. 1, 2, 3, 4. All right. Excellent, excellent. Now this brings us to our next big idea about computer science, and it is this. What is a repeat loop? Well, you just learned. A repeat loop repeats any block or blocks that you put inside it as many times as you say. Makes you much more powerful as a programmer. Now, our next big idea we're going to learn right now as well, and this one sounds a little complicated, but you're going to see it's pretty simple as well. The third big idea is called code efficiency. And let's run back to our puzzles for a sec, because we have a wonderful illustration of code efficiency right back there at puzzle number 6. Let's do it the old way. the way we used to do it. So I'm going to hit the reset button to restart this puzzle. Remember, anytime you get stuck, hit reset, you'll restart the puzzle. And this is the same puzzle we just did. So our bird has to move forward 5 blocks to get to the pig. Well, watch what happens here. I'm going to drag out one move forward block and connect it up here. And if you look up here at the top of every puzzle, you'll see 2 numbers. And these numbers are very important. The first number shows how many blocks you've used so far. And the second number shows how many blocks you should be able to solve this puzzle in. Code efficiency means using as few blocks as possible to solve every puzzle. Now watch what happens if I use too many blocks. Let's say I'm going to solve the puzzle the old way of just stacking up the blocks without using that repeat loop. Every time I drag out a block and connect it, watch what happens to the first number. I'm using 2 blocks so far, but when I snap this one in here, that becomes a 3. Now watch what happens when I put a 4th block on. We snap this one in here. Uh-oh, our number turned yellow. That's a little alarm bell that tells you you're using too many blocks, that you can write more efficient code. Well, we just saw we can solve this puzzle in just 3 blocks by using that wonderful repeat loop. So we take the move forward block, we stick it inside the repeat loop, and look, we've used 3 blocks, and that's exactly the number that we're supposed to use to solve this puzzle. So that's the idea of code efficiency. And so our third big idea in computer science is code efficiency, which means to use as few blocks as possible to solve the puzzle. And so each puzzle is different, but you've got a little report card kind of on the top of every puzzle right here, those numbers up at the top, and they'll tell you just how you're doing as far as how efficient your code is. So those are your next 2 big ideas. What is a repeat loop? What is code efficiency? And you already learned what a program is. So great work. You know, here you are really, this might even be your first hour of programming. You're learning ideas that are common to all programming languages. So you kids are doing great. So now what I'd like to do is let's just take a very short break. You know, I showed you our wonderful contest that we're going to have tonight. And one of you is going to be the lucky winner of the Wonder Workshop Home Robotics Bundle. I showed it to you a minute ago. We can have Dash come up and say hello again. There he is, Dash. But now what I'd like is, Julie, how should people enter the contest to win this great prize tonight?
Entering the contest is so easy. I'm going to give you a link, and we're going to put a little link up here on the screen. And you just need your parent or whatever adult is home to give me a first and last name and an email where I can contact you at if you win. And that's it. So we will take a little coding break here, you guys. So stretch it out, and good luck, everybody. Hey, John.
Sorry, I had my audio off. So here is the link that you use to enter the contest tonight. It's called bit.ly.fcnrobot. So it's bit.ly and then a slash and then FCN for Family Code Night Robot. And that's where you enter your name and your address, your email address to enter tonight's contest. So we'll give you a minute to go ahead and enter the contest. And really, you can enter anytime in the next 15 minutes or so. But we'd suggest you go there and take care of that right now. I think you'll cross your fingers and hope you win the robotics bundle. By the way, as we do this, let me point out one other thing. You'll notice down here on the bottom right of this slide that the way that you program Dash, the robot, is using Blockly, the very language that we're learning together tonight. If you look down there at the bottom right, you'll see a couple of blocks. When, start, forward 50, fast. Those are just blocks of Blockly program that you can use to program Dash the robot to do all kinds of really fun things. So the language we're learning tonight is the very language you use to program Dash. And again, we want to thank Wonder Workshop for providing these great prizes for our National Family Code Nights. So again, the URL to enter is bit.ly/FCNrobot. Julie, have you dropped that into the chat, the contest entry URL?
Yes, it is there, you guys. You should be able to click it directly from the chat or type it in yourself.
Fantastic. Well, we're going to give you about 1 more minute to enter the contest, and then we'll get back to puzzles and coding. And in fact, we don't even have to wait. Here's what you can do. I think what we'd like you to do is go ahead and keep on doing the puzzles that we've been doing. Let me show you the puzzles that we want you to do. But we just did puzzle 6, and so we really want you to do 7 through 9. And then after we do 7 through 9, we'll come back and teach you a couple more important things about computer science. And by the way, puzzle number 9, it's a little tricky, so we like to do that one all together. In just a minute, I'll come back in. We can do puzzle 9 together, and I'll show you something about that some people get a little stuck on. If we do it together, it'll be a lot better. So I'll see you in just a minute at puzzle number 9. And I might add again, if people did show up late, to start tonight's program, you want to go to familycodenight.org/start and click on the Start the Program button if you showed up late. I want to give you one other reminder too, and that is, remember, trade the keyboard after every puzzle. So I hope you're working with a sibling or a parent or a guardian, and that you can give them the keyboard every other puzzle. So trade the keyboard back and forth after every puzzle.
It looks like some of these guys are agreeing with you, John. Puzzle number 9 is pretty tricky.
Oh, puzzle number 9. Many have fallen at puzzle number 9. It is a little tricky. So let's do this one together. It's a fun puzzle. And once you get it, you're going to be all over it. So let's run over to puzzle number 9 together and see if we can't solve it. So puzzle number 9, what makes it tricky is they put a gray block in here that you can't get rid of. Blocks that are gray can't be deleted. Can you solve the puzzle anyway? Oh boy, okay. Well, a lot of the solution to these puzzles is all about recognizing patterns and logic that the bird is going through to solve the puzzle. And so in this case, if you sort of put yourself in the position of the bird in this case has to come forward here. And then from the bird's point of view, he's going to turn right, because if he turns right, he'll be pointing down. And then he'll come down here. And again, from his point of view, he'll turn right again and have to come 2 more spaces forward here to get to the pig. Well, that's a long way to go. And look over here. We only have 5 blocks to get all the way there, and we've already used 2, and we can't get rid of this gray block. What that means is that the bird has got to go all the way here, all the way down here, all the way here in just 3 more blocks. Well, if you put yourself in the bird's position, you can imagine what he has to do first. It's pretty straightforward. He has to move forward, right? So let's start there. So if we move forward, okay, so then the bird will be right here. Progress, good. Now he has to do that again to get right here, right? So let's do that again. Let's drag out the move forward block. And now he's moved forward once, he's moved forward twice. If he tries to move forward again, he's going to bonk right into this wall here. So he can't do that. So what does he have to do? He has to turn right, so that he'll be pointing down. Again, Always put yourself in the position of the bird. You go forward, you turn right, and that'll have him pointing down. So now we'll turn right and he'll be pointing down. Uh-oh, but we have a problem. We just used 5 blocks, and that's all we get to solve the whole puzzle. How are we going to solve this puzzle with no more blocks? This is where patterns come in. And this is part of computational thinking. It's thinking about the patterns that you need in your code to achieve the result you're trying to accomplish. So in this case, our bird, well, we're going to have him move forward and turn right. What else does he have to do? Is there a pattern that we can use here? Well, when he's turning right, he's pointing down. He has to move forward and turn right again. And then he has to move forward again. Well, if you look at this pattern of blocks, here's something really powerful about that repeat loop. You can put more than one block inside it. So I'm taking the whole pattern that we just created for him to be able to go forward, turn right. And now we're going to repeat that how many times? 3 times. All right, let's go through the logic the bird's going to follow. Let's look at the pattern, and let's see if this is going to solve the puzzle. He's going to move forward and turn right once. Then your code tells him to repeat that pattern of blocks 3 times. So he's going to do it again. He's going to move forward and turn right. And that'll be the second time. And then he's going to repeat it one more time because that's what we've told him to do. Repeat this pattern of blocks 3 times. And so what we're going to have here is forward, turn right once, forward, turn right twice. And again, he's going to be pointing down. So when he turns right, he'll be pointing towards the pig. When he goes forward 2 more times, that pig is in serious trouble. Let's take a look and see what happens. Let's run our program. Forward, turn right. Forward, turn right. Uh-oh, we got him. All right, now while we're here, I want to show you one more really cool thing. So that's a nice illustration of using patterns and computational thinking and thinking about the logic of each one of these puzzles. Now, I've been telling you that you're writing code, that Blockly is a real programming language. And let me prove that to you right now. After every puzzle, there's a little button here that says show code. Let's push that and see what happens. You can click this anytime you want. Look at all these characters down here. All of this typing, all of these little words are actually JavaScript. JavaScript is a character-based programming language, one where you type out every character of your commands, and every block you use in Blockly actually represents a line of JavaScript. So when you stack up blocks in Blockly, you're actually writing a JavaScript program. JavaScript is one of the most widely used and popular programming languages in the world. It's used all over by all kinds of professional programmers. So when we say you're really coding tonight, you're really coding tonight. So congratulations, everybody. Now, before we leave, I want to show you one more thing in the next puzzle because it introduces an even smarter, more powerful kind of block that I think you're really going to enjoy. You know, before, when we used the repeat block, we had to tell it how many times to repeat the block or blocks that we were going to put inside it. Now we have a smarter kind of repeat block. Now we have a repeat block that will repeat until it accomplishes its goal. It will repeat until it reaches the pig. So the repeat until block is an even smarter kind of block. And you can see we can use 3 blocks to solve this puzzle, and we've already used 2. We only get 1 more block. Here's our bird. Here's our pig. What block would we want the bird to repeat over and over again until it reaches the pig? I think we know what that would be, right? So that's the beauty of the repeat block and the beauty of the repeat until block. And so it makes you even more powerful, even smarter as a programmer. So go get them. And I will say, go on back to your puzzles. And now I'd like you to do puzzles 9 through 13. Try that puzzle 9 again with the gray block. Remember, stick all 3 blocks of your pattern inside it and have it repeat 3 times, and you'll solve that puzzle no problem. And then I'll see you at puzzle number 13 when we're going to be ready for our next big idea in computer science. I'll see you in just a minute. Julie, how's everybody doing out there?
It looks like people are doing very well. We have some people just wrapping up 13, a couple on 14, 15.
Oh boy. Okay. Excellent. Excellent. Well, I'll tell you what, let's jump over to puzzle 13 then, because I want to teach our next big idea in computer science. It's an important one. It's one I really like. You know, a lot of times when kids start to learn about coding and computer science, they get really nervous they're going to break something or do something wrong. I just want to tell you, our fourth big idea in computer science, there are no mistakes in coding. Just go ahead, click the run button and see what happens. It's all part of the process. And let me show you an example of what I mean by that. So let's go to puzzle number 13 for a second. And you know, you can make all kinds of little errors in programming, and it's just part of the process. Now, in this case, we've moved on to plants and zombies. And if you look, our zombie is up here, and look at the pattern he's going to have to repeat over and over to get all the way down here to the sunflower. He really wants that sunflower. And so what he has to do is come down here and then turn and come here and then turn and continue that pattern all the way down these steps. And if you look here, we only get 6 blocks to solve this puzzle. So we have 5 blocks to use to solve this puzzle. Well, the repeat until block happily is here, and it's a really powerful block. So I know we're going to use that because what we need to do is figure out the pattern of blocks that will take us all the way down to the sunflower. Now, also, we have to watch out for these plants because the plants will eat the zombies if we're not careful. Well, let's try out a pattern and see if it works. Let's try move forward, and then let's turn right, and then let's move forward, and then let's turn right again and see what happens. So let's run our code and see what happens here. So watch our zombie. First step, he got eaten by the plant. He moved forward right into the plant. I think we have a problem in our code. Well, this is what I mean about no mistakes in coding. Just click the reset button and you can start all over again. And that's the beauty of coding. And in fact, it's such a common thing that when we say there are no mistakes in coding, there's even a word for what's called debugging. If your code doesn't work, just look at your code, figure out what's wrong with it, and fix it. It's just part of the process. And in fact, professional programmers, they spend most of their day debugging. Gee, what's wrong? How can we make this code run a little better? It's all a question of looking at your code and figuring out how to make it work better. So in the case of the puzzle we were just looking at, what I did wrong was I didn't see the right pattern. I moved forward instead of what I really needed to do, which was to turn left, right? So let's repeat a pattern again. And this time, the first thing we're going to do, the zombie is going to turn left, so he's pointing down. So let's turn left as our first step. And look, we've used 3 blocks. We have 3 more to go. So our zombie turns left to point down. And then what's he going to do? He's going to be pointing down, and he has to go down here. So he's got to move forward. So now we're going to move forward. So our zombie has turned left. He's moved down here. And remember, from his point of view, it looks to us as though, I'm sorry, I made a mistake. The first step is to turn right. Well, that's a really nice thing. Look, another error in my code. I'm debugging my code as I go. First thing we have to do is pull this down and correct it. So it's turn right. Now we're on the right track. Then we're going to move forward, and then we're going to turn left. Because what's going to happen is our zombie is here. He's going to turn right. He's going to move down here. And when he turns left, remember, he's pointing down. So his left is actually our right, if you see what I mean. Put yourself in the position of the zombie. So when he comes down, he's going to need now to turn left. Then he'll be pointing in this direction. And so what does he have to do? He has to move forward. Now, the problem here is we're out of blocks. We've used 6 blocks, and that's all we get. But think about the pattern. Think about repeating the pattern over and over again until it reaches the sunflower. Have we solved the whole puzzle with just those 4 blocks, those 5 blocks? Well, I think so, because here's what's going to happen. He's going to turn left, go down. I'm sorry, he's going to turn right, move down, turn left, and move forward. Well, if he repeats that over, what's going to happen? He's going to turn right at this corner right here. That'll have him pointing down, move forward. He's going to turn left and move forward. And if he repeats that pattern over and over and over again, he's going to make it all the way down these stairs. And that sunflower could be 1,000 stairs down because the code is so powerful. It will repeat that pattern forever until it reaches the sunflower. Now, one more thing I want you to watch as we run this program. As your code executes, that is, as your program runs, watch, because as each command runs, you'll see it turn yellow over here. And so you can really watch what's happening with your code. So let's run it and watch as the blocks turn yellow as they run.
Brains.
Turn right, move forward, turn left. See how quickly that pattern goes? Right, forward, left, forward. He's going to get all the way down there. He's going to... All right. So the short version on all that is there are no mistakes in programming. There's just errors and debugging, and it's no problem. So don't worry about a thing. Don't be afraid. Just jump in there and play and see what happens. You learn through every little error that you make, and it's just part of the process. This leads us to our fifth big idea, and this one's really one of my favorites. It's called, what is a conditional? Well, a conditional may sound like it's kind of complicated, but in fact, you use conditionals every day. A conditional is an if-then statement. And when I say you use conditionals every day, it's just part of our logic about how we live. So for example, if it's raining, then you take an umbrella. If you're hungry, then you have something to eat. If someone is nice to you, then you say thank you. Those are all conditionals. And so our minds already think in terms of conditionals about all kinds of things that happen to us all the time. Well, it turns out that's extremely useful in coding. Let's look at puzzle number 14. I'll show you what I mean. So in puzzle number 14, we have a new block, and the new block is very handy for us to solve this puzzle. And it's this if block. So the if block is down here. And so now we have gray blocks again, which means we can't get rid of any of those gray blocks. And we've already used 4 of our 5 blocks. So that's the challenge we have on this puzzle. Let's look at what our zombie has to do to make it all the way to the sunflower. Zombie has to move forward and move forward again. And then when he crashes into this wall right here, he better turn left, because if he turns right, he's going to get eaten by that plant. But if he turns left, he'll be pointing up, and then he can continue to just go forward all the way up here until he gets to the sunflower. That's the beauty of the conditional, because look at the logic of the commands over here in our program. Repeat until sunflower. Okay, so it's going to repeat all the blocks inside it as many times as it takes to make it all the way to the sunflower. So the first thing he's going to do is to move forward, and he's going to repeat moving forward as much as he can. So the first thing that's going to happen, he's going to move forward, and then he's going to move forward again. And then if there's a path to the left, what do we want him to do? Well, if he moves forward 2 blocks, if there is a path to the left here, what do we want him to do when he sees that path to the left? We want him to turn left, because if he does, he'll be pointing up. And then when he moves forward again and again and again, it's going to take him all the way up here to the sunflower. So we put turn left inside our conditional. If there's a path to the left, then turn left. And so if you see, we've already used our 5 blocks. You think we've solved our whole puzzle here? I think we have. Watch, because every step he goes, he's going to be asking himself, because we've programmed him with a conditional that says, if there's a path to the left, you have to turn left. Every step of the way, he's going to be asking himself, is there a path to the left? And you'll see, he shoots off a little white ray to the left-hand side where he's looking to see if there is a path to the left. So this is very smart code. It's code that can look and react to what's happening around it, and it makes you an even more powerful programmer. So let's watch what happens, and watch for that little white ray as he checks to see if there's a path to the left. Anytime there's a path to the left, you've programmed him to turn left, and that's exactly what he's going to do. So let's watch.
Brains.
Little white ray. Oh, no path to the left. Okay, now there is, and so he turns left. Every step of the way, he's asking himself, if there's a path to the left, I have to turn left. But because there was not a path to the left all the way up there, he made it all the way to the sunflower. So that's a conditional, and it makes your code much more powerful because it can see and react to what's going on. So that's our next big idea in computer science. What is a conditional? And so now what I'd like you to do is go ahead and complete puzzles 14 through 17, and I'll see you with our 6th big idea. Oh, and by the way, we do have one more thing coming up before we end today. We have that prize drawing coming. So I hope everybody's been able to enter the prize drawing. Julie, maybe drop the URL for the prize entry one more time if there's time. And we will look forward to seeing everybody for the last big idea. And then we'll get to our prize drawing and a couple of things to wrap up our family code night. So see you in just a minute around puzzle 17 or 18. By the way, I'd just like to say, don't worry if you're going slowly, if you're going quickly. We're going to show you how to finish these puzzles anytime you want. You can always come back later on. So don't worry about how far you've gotten. It's all good. No matter what puzzle you're on, you're learning, you're doing great, kids. So don't worry about how fast you go or how slow you go. It's all part of the process.
And like John said, we have our final moments to enter the contest if you guys want to try and win that Dash bundle. I have put the link in the chat a few times. I'm going to put it in one last time. Last calls, everyone.
There we go. Last call. Enter quick if you want to have a chance to win that Dash Robotics Home Bundle. We're going to do a drawing right at the end tonight, and we'll see who wins that prize. All right, everybody, we're coming down to the end of our National Family Code Night, and I want to make sure we have time to wrap up at the end. So I think what we're going to do is jump over to puzzle number 18, and we'll cover our last big idea and get on with a few things to wrap up our program here. So puzzle number 18 introduces another new kind of block, another even more powerful kind of block. And this one is a different kind of conditional. Now, we've moved on to characters from the movie Ice Age. And you may remember from the movie Ice Age, there was a little guy named Scrat. And Scrat was out of his mind to get, remember what it was? Acorns. He loves acorns, right? Well, here's Scrat right here in our puzzle. And Scrat needs to go forward. And then he needs to turn left and go all the way up here. And then he needs to turn left again and go all the way down here to get to the acorn. And we only have 4 blocks that we can add to achieve this. Well, as I said before, we can put blocks, patterns of blocks inside other blocks, and that will repeat the pattern until we solve the puzzle. So I'm pretty sure we're going to need this repeat until acorn block. What pattern do we want to repeat that will get Scrat all the way to his acorn? Well, that's where our if-else conditional comes in. Because the way this works is it gives you a way to tell the code to instruct 2 different options depending on what it sees. And so if it sees a path ahead, that's the first part of our conditional. If then, remember, a conditional is if then. Now, if there's a path ahead, what do we want Scrat to do? Again, put yourself in Scrat's position. And if there's a path ahead, well, we want to move forward, right? Anytime there's a path forward, we want him to go ahead and move forward. But look what happens. As soon as he goes forward one time, he's going to bonk into this wall right here. He can't move forward more than 1 block. That's what brings us to the else part of our conditional. If there's a path ahead, move forward. If there's not a path ahead, else, then what do we want him to do? Well, think about the logic of it. If he's just bonked into this wall, and look, there's a path up here if he turns left that will take him forward again. And so here's our logic. Repeat this pattern until the acorn. If there's a path ahead, move forward. So far, so good. If there's not a path ahead, else, excuse me, what do we want him to do? We want him to turn left. Well, we just used our fifth block, and that was all the blocks we had. Have we solved the puzzle? So let's think about this. He's going to move forward here because we've given him the command. If there's a path forward, move forward. So he's going to move forward. And then if there is not a path forward, else, he's going to turn left. Well, when he turns left right here, he's going to be pointing up. And then what's he going to do? He's going to obey the first part of the conditional that we just programmed him to do. So if there's a path ahead, what's he going to do? He's going to move forward. If there's a path ahead, he's going to move forward again. If there's a path ahead, he's going to move forward again. But look, up here at this corner, he's going to bonk into this wall again, right? But that's where the else part of our conditional comes in. If there's not a path forward, what have we told him to do? Turn left. And look what's going to happen. He's going to turn left. He's going to be pointing down here. And then all the way down this home stretch here, there's going to be a path forward. So he'll just move forward every step of the way. So let's go ahead and run our code and see if it works. And again, watch over on the left and you'll see the code run, and also watch every step he takes. He'll shoot that little white ray off in front of him now to see if there's a path forward. And anytime there's a path forward, he's going to move forward because that's what we programmed him to do. So let's run our code and see what happens. There's this little white ray. Oh, no path forward, so he turns left. That's the else. Oh, no path forward, so he turns left. That's the else conditional, and he gets there all the way down to the acorn. Cool. All right, I want to show you one more thing about this puzzle that's kind of interesting. Why didn't he turn left right here, right? Because our code says turn left. Well, the reason is that he came here, and the reason he turned left here is that there was not a path forward. That's how the else part of the conditional kicked in. And the same thing up here. He bonked into this. There was no path forward, so our code told him to turn left. But look, as he comes down here, he doesn't turn left here. Why? Because the first part of the conditional still works. If there's a path forward, go forward. And so sure enough, he makes it all the way to the end and to the acorn. So however far you've gotten tonight, congratulations. I want to encourage everybody to go all the way to puzzle number 20. And I'm going to show you how to do that in just a second. And if you go to puzzle number 20 and finish number 20, code.org gives you a really fun little surprise. So everybody gets that if you finish puzzle number 20. I urge you all to finish whenever you can. And as I said before, we'll show you how to do that right now. So one of the really important things about Family Code Night is this is really just the beginning. Oh, and by the way, here's our sixth big idea. It's the if-else statement that makes conditionals smarter. If one thing, do this. If not, do something else. Now that's a very smart piece of code. All right, so now what's next? And this is what I wanted to talk to you about here a little bit. First of all, the one thing you can do as far as what's next is you can continue anytime. You can come back to familycodenight.org/start. That will always bring you back to that start the program link and bring you back to puzzle number 1. And you can go back through these puzzles as many times as you like. And you know, there are those little videos that pop up. There's all kinds of fun to be had here. So go on back to familycodenight/start anytime you want. The next thing you can do is everyone who attended tonight who enters the contest, we're going to send everybody a couple of little prizes. One is this little summary of the 6 big ideas that we learned tonight at Family Code Night. So we'll send you that. In addition, everybody gets a Code at Home family pack. This is a really nice summary of all kinds of free online computer games, coding games that you can use at home. They're all free and they're at various levels, all the way up to learning JavaScript through a self-paced program called Grasshopper from Google. So there's wonderful learning platforms out there that you can take advantage of. And we've described a bunch of them here in the Code at Home family pack. Everyone who entered the contest is going to get that. We're going to send you an email as soon as we wrap up tonight. Now, this is all about coding at home and what you can do at home. And one other thing we're going to give to everybody here is we're going to give everybody a badge. Everybody gets a badge that said, "We did National Family Code Night." So congratulations, everybody, especially you younger kids. Congratulations. you did your National Family Code Night, and really in your first hour of coding, maybe you learned some big ideas about computer science. So congratulations, everybody. If you can, please post this online with the hashtag Family Code Night on Facebook or Twitter or other social media. We'd love to see these things pop up all over the place to encourage others to participate with us. And this actually brings us to the next part of what we're talking about. At the outset here, I talked about we've created a new organization called CS is Elementary, and this is a movement for national computer science education for K-5 children in every school in the country. Tonight, we've got more than 100 schools that have invited their families to come and join us here tonight. We have a new website called CS is Elementary. I'd like to show you just one thing about our website that I think you might be interested in. So CS is Elementary is this new organization. This is our new website. And we have every school in the United States listed on our national schools map. And so you can come here to our website. You can find your school. You can see if it's a Family Code Night school. Any school in the country is listed here. And the first thing we want schools to do is to invite their families to a National Family Code Night like we did tonight. It's super easy to do. You enter the name of your school right here. This is mostly for teachers and principals, but Old Mill Road School, for example, in Merrick, New York. And then you pick the date of an upcoming Family Code Night, and that's all it takes for a school to sign up. And then we send an invitation to the school. They send it out to the families like most of you probably received tonight. So we urge everybody to do that. The second thing we'd like you to do as parents especially is, you have every right to ask your school what they're doing in computer science. And one of the things that we enable through our national schools map, which was right down here, it has every school in every state in the United States. And in our CS Elementary program, we've been working with a bunch of several model program states, among them the state of Pennsylvania, by the way, where almost 200 schools have signed up to participate in our National Family Code Nights program. We really appreciate working with Patton there in Pennsylvania, and in other states like Maine and Texas and Virginia and Rhode Island, other states around the country. We're working with states to encourage all